Hello everyone. In this session we'll discuss about program control. Now program control are the instructions which alter the sequence of the program's execution. That means it changes the value of the program counter due to which the execution of the program changes. Now the value in the program counter changes, which results into the change in the flow of execution of the program. So the sequence of execution of the instruction changes. That means if we are having 10 line of programs, in that if we start with first line, second line, and on third line if we are having certain program control instruction written, then in that case we are supposed to change the program counter. That means if the program sequence from line number 3, instead of line number 4 we are supposed to go to directly line number 6. So that is the change in the sequence of the program. So it can be achieved by means of program control instructions like we are having branch, jump, skip, call, return, compare and test. We are knowing that branch, that means it is unconditional jump, it is unconditional branching. Wherever we specify the address we need to branch. Same way we are having jump, then skip, that means we can skip the next instruction, call, that is our subroutine call, return, that means returning from the subroutine, compare, test and so on. So these are the examples of program control instructions which changes the execution of the program. Now let us move further. Now these all are unconditional jumps or unconditional branching. That means there is no certain condition based on which they can jump or alter the sequence of the execution. But we are having one thing that we are supposed to go through is the status bit conditions. Now these status bit conditions are also termed as flag registers. Let us see one by one. Status bits, that means the value would be either 0 or 1 because it is a bit. Now we are having 4 status bits, that is starting with V, which is overflow, Z stands for 0, S stands for sign bit and C stands for carry. Now they would be set or reset based on the ALU operation carried out into the CPU. Now let us discuss this bit before understanding the operation. That means overflow. Now this V overflow is based on certain bit if extra bits are generated into our operation. We'll see to do it on later part. Then 0, what we are having is if the output of the ALU is 0, then this Z flag is set to 1. Otherwise it is set to 0. Sign flag, if number is positive then sign flag is 0, if number is negative sign flag is 1. Then carry, if the output of the ALU operation generates carry, then C is set to 1, else C is set to 0. Let's see how these flags are affected. Now this is 8-bit ALU which performs arithmetic or logic operations on our data. That is, suppose we are having two operands A and B of 8 bits on which we are having certain arithmetic or logic operations carried out. Say for example arithmetic operation addition is performed on A and B. So but natural we know that it may happen that the extra carry bit is generated into it. That means 8 bits, so starting from C0 to C9 carry bits, if as it is 8 bits, so if the addition operation performs the if the addition operation is performed on the carry, so if the addition operation is performed on this operands A and B, then the carry bits C0 to C7 may be generated. But we know that extra carry may also be generated, which we term it to be C8. So if C8 is generated, then we are knowing that the carry is generated and it reflects our carry flag. That means the C flag or C status bit is set to 1. If we move further, then last two carries, that is C7 and C8, the XOR of these two carries If it comes out to be 1, then we can say that the overflow has happened. Now this is the case mostly occurring when we are having negative numbers represented in 2's complement form. So the last two carries C7 and C8, if the XOR of these two carries is generated to be 1, then we can say it is an overflow condition and V flag is set to 1, otherwise it is set to 0. Now moving on to the next flag, that is S, that is sign flag. Now sign flag is reflected to 1 or 0 based on the output of this 8-bit ALU. That means if the F7 bit, because we are knowing that if number is positive, then the most significant bit of a number is represented to be 0. That means if F7 is 0, then we can say that the number is positive. And if F7 is 1, then we say that the number is negative. And lastly, we are having 0 flags, 0 status bit Z. Now Z is set to 1 if output F0 to F7 all the bits are 0, then we can say that the 0 flag is set. Otherwise it is set to 0. Now all these 4 bits, that is C, S, Z, V, are reflected based on the arithmetic or logic operation carried out on this 8-bit ALU. But based on this 4 status bits, we are having certain program control instructions. Now based on this, let us see them. Now as you can see, these are conditional branch instructions based on status bits. That means BZ, that means branch if 0 to some specific address. That means if Z bit is set to 1, then we need to branch. Similarly BNZ, branch if not 0. That means if Z bit is set to 0, then we are supposed to jump. Otherwise not. So these are the instructions based on our status bits, that is BZ, BNZ. BC, BNC, that means branch if carry, branch if no carry. Then BP and BM, branch if plus and branch if minus. Now they are based on S flag, S status bit. Now carry, this is based on C status bit. Same way we are having BV, so branch if overflow, and BNV, branch if not overflow, so that is they are based on V flag. So if V is set to 1, then in case of BV we need to branch. If V is set to 0, then in case of BNV we need to branch. So these are the 8 instructions which are conditional instructions based on the status bits what we have discussed earlier. But we are having certain unsigned comparison instructions also, like BHI, branch if higher. That means if we are having 2 operands A and B, then if A is greater than B, if A is higher than B, then branch, otherwise not. Same way branch if higher or equal, then branch if lower or equal, then branch if lower. That means if A is less than B, then jump or branch, otherwise not. Same way we are having BLOE, that means branch if lower or equal, branch if equal, and branch if not equal. So these you can see that they are conditional statements which changes the flow of sequence based on the conditions. Now next we are having is signed compare condition. These all are for unsigned comparison, but now if the number A and B are signed, then we need to go for BGT, that is branch if greater than, BGE, branch if greater or equal, BLT, branch if less than, BLE, branch if less or equal. And this is same for both branch if equal and branch if not equal, for signed as well as unsigned. So as you can see, these are conditional branching statements. Now if we compare it with our regular programming languages like C language, then we are using relational operators to perform such operations, that is less than or greater than, less than equals to, greater than equals to, not equals to. All these operations, that is relational operators, will be converted to these instructions when they get converted to assembly language program. So when our higher level language program gets converted to lower language programs, they are basically converted to these instructions in assembly language code. So now it should be clear to you how our higher language operators, or we can say the relational operators or arithmetic operators or any operators we are using, they gets converted to the corresponding instructions in the background when we are dealing with assembly language program. So this is what is all about program control instructions.